In this unit, we're going to see how we can take what we learned about Laplace transforms and apply it to circuit analysis. So as we've said before, using our Laplace transform means that we're going to be able to analyze our circuits in the S domain or the frequency domain. And when we're doing that analysis, we're going to be working with algebra, and that's as opposed to differential equations that we'd have to deal with if we were working in the time domain. So what we're going to do in this video is we're going to note the steps of applying our Laplace transform to circuit analysis. So steps for our Laplace transform analysis. So maybe not surprising, our first step is going to be transforming the circuit from time domain to S domain. So transform circuit from our time domain, so I'm just going to call that T domain, to our S domain. And so I'm kind of being vague here about transform circuit. So we're going to come back in the next few videos and we're going to look at how we can transform individual circuit elements. And then of course we can put that all together in order to transform a circuit. So our second step is just going to be solving the circuit using standard analysis techniques. So solve circuit with standard analysis techniques. And so of course solving the circuit means maybe we're looking for a particular voltage or a particular current. That's just going to depend on the problem. And so what's included when I say standard analysis techniques? Well, all of the techniques that we looked at when we were analyzing DC circuits are going to apply here. So all techniques from DC analysis are going to work in our S domain analysis as well. It's just we're going to be dealing with functions of S as opposed to numbers. And so this includes, for instance, everything from our node voltage analysis. So we could use our node voltage method. We could use our mesh current method, and we'll look at examples later on of using how to use each of these. We can also use things like superposition, voltage, current divider. So again, anything that we used for DC circuits is going to be valid here, and we'll, again, in our next few videos, we're going to see how we change our elements to our frequency domain, and we see it's just going to be sort of the same basic process, slightly different numbers. So our third step then is, after we've done this, we're going to take the inverse transform, and that's going to be our solution in the time domain. So take inverse Laplace transform of solution, and by solution I mean whatever voltage or current that we were looking for. And so that's going to give us our solution in the time domain. And so looking at these three steps, so this is all the only steps we have, we see really the only new step is this step one. So this is the only new step or only new thing that we've not seen before, because of course we've been doing circuit analysis for all of our previous units. We looked at node voltage explicitly when we were doing op amps, when we were doing filters and resonance. And then this inverse transform, the idea of doing our inverse transform down here is something that we hit on pretty hard in the previous unit. So we know we can do partial fraction expansion to find an inverse transform for most cases, and then we use our known tables, so our known pairs and our properties, to find inverse transform. So really what we need to focus on is this step one of how do we transform the circuit from the time domain to the S domain. And so before we move on to the next few videos to look at this, one other advantage that I want to highlight again, which we've mentioned before, is that when we're doing this type of analysis with our Laplace transform, we're getting our natural and our forced response at the same time. Or another way to say that is we get our transient and our steady state at the same time. And so we're going to see that explicitly in an example later on. So we attain our transient and our steady state at one time. So basically we just do the analysis one time and we're able to get both of those. Again, so in the next few videos we'll look at how to transform the circuit, and then the rest of the unit is just going to be looking at examples of how we can apply Laplace analysis to circuits.